Now let's do the other type of work problem, that is filling the swimming pool. Okay, the question is, how many hours will it take to fill the pool? There's no water going in, so it's indefinite. Try that sometime. You could have a cup and then have no water going in and start measuring how long it takes to fill it. All right, let's have some water going in. Here we go. When you use this hose, it takes 10 hours to fill the swimming pool. Okay, in that case, how long would it take to fill the swimming pool? 10 hours, of course, but let's humor me. Okay. Work is rate times time. Work is one swimming pool. The rate is, we don't know. We're trying to find out. Rate of the small hose. How long does it take to fill the hose? 10 hours is said. Okay, so what's the rate? Is 1/10. Okay, how long does it take to fill the swimming pool? If fill one swimming pool, it is rate times time. Okay, so what is time? 10. So it's 10 hours to fill the swimming pool. But that's what I said. So when a problem is like this, it's that simple. There's nothing to think of. But of course, that's not what we are going to study here. Let's get more complex this time. Okay, how complex can it get? We will have two hoses. This hose takes 10 hours to fill the swimming pool, and this more stronger hose takes 7 hours. It will take less time, you see. It's got more water coming in to fill the swimming pool. How long would it take if they work together? Oh, okay, now let's do the swimming pool of the smaller hose first. It takes 1 hour to fill at the rate of the smaller hose for 10 hours. To fill the one swimming pool, the rate of the medium hose, not equals 7 hours to fill it. Okay, now we want to know how long it takes to fill the whole swimming pool. Whole swimming pool is 1. Is the rate, their rate add, you know. Here, if you work the same amount of time, you can add the rate. So their rate will have time. How long is that? Let's substitute. R sub S is 1/10, you see. And R sub M is 1/7 T. So let's, for our sanity, let's do common denominator. So how long would it take? 70/17 hours. Okay, that is roughly what? I would say 3 some hours. Not even 4 hours, right? 4 hours. No, 4. A little bit over 4 hours. So here, this alone could fill in 7 hours. So if there's a help there, of course it's going to take less than 7 hours. So I knew the number was less than 7 hours for sure, but didn't know exactly how much. But let's get a little bit hairier than this. Now, how hairy can it get? Haha. We got 3 hoses. So this one can fill in 10 hours. This can do in 7 hours. And this can do 5 hours. Powerful stuff. What if they work together? How long would it take? Okay. I think I will run out of the room, so I will write small. So a smaller one takes 10 hours. And to fill one whole swimming pool, the medium one takes 7 hours to fill whole swimming pool. The large one takes 5 hours. What if they work together? How long would it take? So I will just use this one, adding work here. The work done by the small one during the time that it takes one swimming pool together, how long would it take? We say we don't know. It takes T here. So I will use this work definition this time. The smaller one will work for time. And the medium one will work for time. And the large one will work for time that we do not know. Altogether, it will fill what? One swimming pool. So one swimming pool will be filled by the rate being added during the time that it takes the swimming pool. Okay, so now 1 equals, well, you know the numbers, right? R sub S is 1/10. When you're experienced, you just go straight for this line here. I'm showing you all these steps to show the reasoning behind it, but you should do these problems enough that you can just dive into this line in one step. Okay, I will not do the rest. The rest is just arithmetic. But here I'd like to show you. Oftentimes the problem would say the hose was turned on 5 minutes late or 2 minutes late, something like that. Here we are assuming hours here. If they said the hose was turned 30 minutes late, you got to subtract 0.5. Okay, do not subtract 30. Okay, and here's one more twist that I'd like to show you. Sometimes they drain at the same time. Look at this. This hose can drain the pool in 20 hours. Notice the drain has to be a lot slower than the filling. What if this can drain in 2 hours? You never fill it. It's basically essentially the bottomless jar, you know. You will never fill that. So this is typically larger hours because it drains slower, which is different from reality. I think most places would drain a lot faster than fills, but this is math problem, so got to make some sense. So it's slower. What if, you know, all three hoses are going and drain is also open? How long would it take? This is how you do. You got to take away the drain rate times time. So this is the work destruction. This doesn't happen in house painting because, you know, nobody goes around erasing the paint job you just did. But in bathtub or swimming pool draining or filling problem, you have this one coming. So you put the draining here, R sub D times T. So in this case, I said it was 20, right? So you would just subtract 1/20 from the end. You notice here, if it could drain in 2 hours, for example, you would put 1/2, and that number is a lot bigger than any of these combined. So you would get negative time. Essentially telling you swimming pool was full 3 hours ago before you start draining. That's what it's saying here. Okay, now you know how to do arithmetic. So this is how you do the computation and get the answer. Here I told you an important concept. The work being added, it doesn't have to be just two. It could be any number of workers that you want, and they don't even have to start at the same time. If they arrived late or arrived early, adjust time for each guy separately here. And also, it doesn't have to be all constructive. Somebody could be draining the pool that you're filling. No problem. Just it's minus here, you see. Just stick in the minus and do the computation and you will get the answer. You just mastered the work problem. Congratulations.